Let's talk for just a few minutes about normal distribution. Data can be distributed lots of different ways, but when they say it's been normally distributed, then we would use this information to help us solve problems. So sometimes our data is spread to the left, sometimes our data is spread to the right, sometimes it's all jumbled up. But when it follows like what we call a bell-shaped curve of our data, it's called normal distribution. And in these problems, they'll use those words so you'll know that this is what you need to use to solve the problems. Some examples of when normal distribution occurs is when you have data about, say, heights of people or the size of things produced by machines, like their margin of error follows a normal distribution curve, error in measurements, blood pressure, or marks on a test. Like normally test scores follow a bell-shaped curve of how the data is spread out. There's usually like the C's are in the middle, you have A's on one end, and D's or F's on the other end, and normally it distributes that way every time. So let's look at a little more information. So again, I said you use the normal distribution curve when it is mentioned in the problem that the data has been normally distributed or is called normal. Other than that, then you might be needing something else for the problem. In the middle of our curve, we have the line straight down the middle that would divide it perfectly in half, and that is where the mean is located, and the mean is equal to the median, and it's equal to the mode in normal distribution. So we have 50% of our data would fall to the left of our mean, and 50% of data always falls to the right of the mean. Like I already said, mean is equal to median is equal to the mode. So in case you're asked about those, the main one we talk about is mean. But if they ask about the median and the mode, those are all equal. There is symmetry about the center. So notice it's divided perfectly in half. And there are 50% of your values are going to be greater than your mean and 50% are less than the mean. So other information we can figure out is when we talk about standard deviation. A standard deviation is an amount that takes you to the first tick mark on our normal distribution. We normally think about all of our data falls within 3 standard deviations of the mean. So 68% of the data falls within 1 standard deviation of the mean. So +1 or -1 from that mean, 68% of our data would fall there. We have 95% of our data falls within 2 standard deviations of the mean. So 2 above the mean and 2 below the mean would represent 95% of our data. So that's a lot of information that's really right around our mean. And then 99.7% of our data, so notice that's really close to 100% of it, falls within 3 standard deviations of the mean. So you just have a tiny little piece that might be left over, but it's enough that we consider that to be all that we need to look at when we look at normal distribution. More than that, and we're just being picky. So write these down in your notes, and I'm going to show you one more picture of the curve. And I think it's helpful to draw these separate ones on your paper to help you solve problems that will deal with different parts. Like sometimes you're asked about half of the data. That one's easy to look at. Sometimes you're asked about 1 standard deviation, so that one would be easy to help you solve those problems and just look at that graph. Sometimes they ask you about 95% of the data. You could just look there. And then sometimes they ask you about 99.7% of the data, and you could look here to see exactly what is that talking about to help me solve the problem. Now the other picture I want to show you is all of that put together. So here is the normal distribution curve all put together now. We have within 1 standard deviation, there's 68% of our data. So there's 34% on either side of the mean, right there in the red. And then you have 95% is within 2 standard deviations. So the percentage between the 1 and the 2 on each side, you would get by taking 95 minus the 68 divided by 2 is where I got the 13.5%. But that's still total 95%. It just helps you when you're answering questions because they could ask you something about just this portion of the graph, for example. And then the green is where I took 99.7% of the data minus the 95% left me with 4.7%, and then split evenly here, that would be 2.35% of my data. So if I'm only asked about a value right there, then I have that already written down in my notes and I don't have to recalculate it. So I wrote where I got these numbers from, but they go with what you just wrote down on that other board. And hopefully you did write that down. Because like I say, depending on what they ask you about, the ones over here might be easier to look at because they're specifically about just the first standard deviation, the second standard deviation, or the third by themselves. And sometimes we're asked about, what about between values? So that's when this one would be helpful. Also, something good to know is the area underneath this curve. If you're ever asked about that, that is always equal to 1. We're going to focus on problems that deal with the data, but just in case that comes up, it's a good thing to make a note of while we're talking about normal distribution. And we say, this is one more thing we need to write down, the z-score. The number of standard deviations from the mean is also called a z-score. To convert a value to a z-score, like if they give you a random value in your data and you need to know what is that z-score, a simple way to calculate it is to subtract the mean, divide by the standard deviation. Always keep a marker in case something's missing. That's supposed to say standard deviation. So our formula is z for z-score is equal to the value that you're given, you'd have to be given that value, minus the mean, that's the little symbol for mean, divided by the standard deviation. So notice, subtract those first, and then divide by the standard deviation. And so if you're given a random piece of information that's just somewhere in the data, you could easily calculate how many standard deviations is it from the mean, which is its z-score. So I'm going to put some examples for normal distribution on another video. This video was just so you could take notes on how it's set up, and